Professor K. Srinivasarao, sir.
Yes, madam.
Good morning, sir.
Good morning. Good morning.
May I start our program, sir?
Yes.
Okay, thank you, sir. Respected Dr. Sister Teresa Gade, the correspondent, Dr. Shaini KP, the principal of the JMJ College, and all FDP participants, good morning, one and all. I, B. Bharati, lecturer in mathematics and one of the member of FDP organizing committee, extend a graceful welcome to all the participants to this national level faculty development program on effective pedagogy for science, jointly organized by Department of Mathematics and Physics, JMJ College for Women, Tenali. It is said, creativity is thinking of new things, but innovation is doing of new things. With this quote, I extend a fabulous welcome to our innovative and eminent professor, Dr. K. Srinivasarao, Head of the Department of Mathematics, Sri Chandrasekharendra Saraswati Viswa Mahavidyalaya, Kanchipuram, Tamil Nadu. MATLAB is an efficient, user-friendly, interactive software package which is very effective for solving engineering, mathematical and system problems. It is a high-performance, fourth-generation programming language which is used for technical computing. Now we are privileged to have the renowned resource person, Dr. K. Srinivasarao sir, to share his knowledge on MATLAB. Once again, I invite you all to today's stimulating session. Now I request Mr. Murali, the computer programmer, to invoke God's blessings through prayer song.
When upon life's billows you are tempest tossed, when you are discouraged thinking all is lost, count your many blessings, name them one by one, and it will surprise you what the Lord has done. Count your blessings, name them one by one. Count your blessings, see what God has done. Count your blessings, name them one by one. Count your many blessings, see what God has done. Are you ever burdened with the load of care? Does the cross seem heavy you are called to bear? Count your many blessings, every doubt will fly, and you will be singing as the days go by. Count your blessings, name them one by one. Count your blessings, see what God has done. Count your blessings, name them one by one. Count your many blessings, see what God has done.
Thank you, Murali, for showering God's blessings. Now, may I call upon Dr. S. Uma Maheswari, convener of the FDP and head of the Department of Mathematics, to introduce today's resource person, Dr. Srinivasarao sir.
Good morning, all. Myself, Dr. Uma Maheshwari, Head of the Department of Mathematics, JMJ College for Women, Tenali, extend a warm welcome to all the faculty members and research scholars of the FDP. It gives me a great pleasure to introduce today's honorable eminent resource person, Dr. K. Srinivasarao, sir, the professor and head, the Department of Mathematics at Sri Chandrasekharendra Saraswati Viswa Mahavidyalaya, Kanchipuram, Tamil Nadu. Sir received his Master of Science degree from Jawaharlal Nehru Technological University, Hyderabad, Master of Philosophy from MK University, Madurai, Doctorate from Acharya Nagarjuna University, Guntur. Sir is having teaching experience of 20 years in post-graduation level and 10 years at graduation level at various universities and colleges. He served as a principal for 2 years at Harshavardhana PC College of Computer Science, Cherukapalli. He authored 4 textbooks on different topics, including Introduction to MATLAB, Numerical Methods with Programs in MATLAB, etc. He published 50 research articles and 11 conference proceedings in different research journals and magazines. He acted as a resource person and chairperson in many national and international conferences, workshops, and seminars. So far, he delivered 66 invited lectures, 16 chairperson lectures in academic and research programs. Many of these lectures are related to applications of MATLAB. He is a renowned research guide. Under his able guidance, 7 PhDs and 22 MPhil degrees have been awarded to the scholars. He has carried out many distinguished roles in SCS Visva Mahavidyalaya. He has received many awards for outstanding accomplishments. Some of them: IMRFD Distinguished Inspiring Best Teacher Award 2020 from the International Multidisciplinary Research Foundation AP. Best Teacher Award for the academic year 2016 from SCS Visva Mahavidyalaya. Best Scientist Award 2018 from International Multi-Research Foundation, Chandigarh. Best Paper Award in International Conference on Mathematics, Statistics and Computer Science at Asian Institute of Technology, Bangkok, Thailand in 2018. Best Paper Award in International Conference on Contemporary Approaches in Mathematics and Emerging Engineering Trends by Vinayaka Missions University in 2017. Best Paper Presentation Award in 5th International Conference on Current Scenario in Pure and Applied Mathematics at Coimbatore, Tamil Nadu in January 2022. Best Paper Presentation Award in the International Conference on Mathematical Engineering Applications for Sustainable Development at the University of Malaya, Kuala Lumpur, Malaysia in August 2019. Best Paper Award in International Conference on Data Analytics and Mathematical Modeling organized by Vinayaka Missions University in May 2016. He has been on the editorial boards of several mathematical journals and magazines, including Journal of New Frontiers in Mathematics and Statistics, published by Institute of Mathematics and Management, Sri Lanka, Syria Journal of Mathematics, and Mathema Sciences Today, an e-magazine of Society of Mathematical Sciences, AP and Telangana. Professor Srinivas Rao sir is keenly interested in MATLAB program and dissemination of MATLAB ideas. Sir has been in constant demand due to his new findings, gets invitation from various destinations to share his knowledge as the keynote speaker, invited speaker, etc. at international research forums in Thailand, Malaysia, and India. We are privileged to have him with us to impart his knowledge and wisdom on today's topic, pedagogical learning of MATLAB. I welcome again Dr. Srinivas Rao sir for today's session. Thank you all.
Thank you, madam. Good morning to one and all, and welcome to final day of this program. First of all, my sincere thanks to respected principal, Dr. Shini madam, and Dr. Yashoma Maheshwari madam, convener of FDP, for inviting me to this program. Shall I share my screen, madam?
Okay, sir.
visible.
Is it visible?
Yes, yes, sir.
Yes, sir.
Yes, sir. Thank you. Yes, today, I would like to give a talk on pedagogical learning of MATLAB. In this talk, I would like to cover what is MATLAB, what is the necessity to study MATLAB, what are the different MATLAB windows, basic MATLAB operations, inbuilt mathematical, I want to explain inbuilt mathematical functions, how to create arrays and matrices, some linear algebra concepts, like how to perform elementary row operations, column operation in a matrix, so that how to write our own programs to solve system of equations, how to find out eigenvalues and different kinds, and so on. And finally, I'm planning to close with how to plot 2D and 3D plottings. First of all, what is a MATLAB? MATLAB is an efficient, user-friendly, interactive software package which is very effective for solving engineering, mathematical, and system problems. If you see this one first sentence, MATLAB is an efficient, user-friendly, interactive software package. MATLAB is an user-friendly software package. MATLAB is an interactive software package. MATLAB is an efficient software package. So what does it mean? MATLAB is an user-friendly software package. It means there are so many operating systems are available in the market. Linux, Microsoft Windows, Ubuntu, Mac, and so on. But most of them are using Microsoft Windows operating system because it is a user-friendly software package. By clicking mouse, you'll get the output. Similarly, MATLAB is a user-friendly software package. A layman can learn MATLAB. MATLAB is an interactive software package. MATLAB interacts with you when you are in MATLAB environment. That means it gives ideas to solve your problems. That's why you call it as an interactive software package. MATLAB is an efficient software package. No doubt, it gives 100% accurate results. That's why we call it as an efficient software package. Based on these features, MATLAB became very popular and familiar nowadays. MATLAB operations. These are the common we use: plus for addition, minus for subtraction, asterisk, that is star for multiplication, right division for division, exponentiation, hat symbol, hat or cap. We use these symbols. This hat symbol, this asterisk, this right division. It's mathematical functions. If you want to find out a square root of a function or square root of a number, we use sqrt of x. We have to use open braces. Open braces. So if you want to find natural logarithm, we have to use log of x. If you want to use log x base, if you want to use a function log x base 10, we have to give log 10 of x. Exponential function, e power x. Exponentials, we use exp of x. If you want to find out sign of any value, here again the value it holds for any valid for any function where the arrays matrices. Sign of x. If you want to find cos values, cos of x. Inverse trigonometric function, we use a cos x. Like this. With this brief introduction, I am going to open MATLAB so that you will get an idea. So this is the MATLAB icon. That means MATLAB is installed in my system. If you double click, so this is called MATLAB window. Here there is a cursor, double greater than, and cursor is blinking. That means MATLAB is ready to accept your commands. Just I will spend 2 to 3 minutes on basic operations. Suppose 6 plus 3. This is the input given by the user. If you enter MATLAB gives the answer. This is the input given by the user. This is the answer given by MATLAB. Output. Similarly, 6 star 3. 6 into 3. 6 right division. Okay. Similarly, square root. SQRT. SQRT of 3. Square root of 3. Square root of a number. EXP of 2. EXP of 1. Exponential E value. So sine. How to enter pi? How to enter pi? It is become PI. PI. It is very easy to remember all these basic commands. So functions, inbuilt functions. Sine pi by 3. Sine pi by 3. Root 3 by 2. So like this log LOG of 2. This is log 2 to the base C. Whereas if you want to find another base, log 10, this value is log 2 to the base 10. Like this, these are the basic commands which I explained earlier. So my first question is to the audience, how to find out square root? So suppose if you want to find out 3 power 2 exponential values, cap 2, 3 power 2. So now I want to find out sine square pi by 3. Anybody? If you have an idea, sine square pi by 3, I want to find out sine square pi by 3. How to enter that command? How to enter the sine square pi by 3? Anybody? Am I audible?
Yes, sir.
No. Sir, I want to find sine square pi by 3 now using MATLAB. Anybody? If you have an idea, please enter the command. I want to find out sine square pi by 3.
Chat box.
Chart box. Use chart box. Sati Babu Reddy. I am copying your command. Sine square pi by 3. I am copying your command. I am executing your command in MATLAB. This is the command you have given. MATLAB showing an error. Sine square pi by 3. Anybody? Others? Don't use mic. Just use chart box. Anyway. Okay. Actually, sine square theta is sine theta whole square. Sine theta whole square. So we have to give sine of pi by 3. Pi by 3. Whole cap 2. Then only it displays the answer. But actually, sine square theta is sine theta whole square. So like that only we have to give the commands to sine theta is a function here. Sine of x is a function. Sine x whole square. Root 3 by 2 whole square. 3 by 4, 0.74. Similarly, suppose I want to find out 2 by 3 by 4. 2 minus 3. I want to find out 2 minus 3 by 4. That is actually the value is minus 1 by 4 minus 0.5. Am I correct? 2 minus 3 by 4. If you give as it is, it is giving 1.25. Actually, the answer is 2 minus 3. The numerator is minus 1. Denominator is 4 minus 0.5. Whenever we have a numerator 2 terms, we have to use the brackets here. With these things, we have to remember while executing the commands. Command window is, we give the commands to MATLAB through this window. That's why we call it as a command window. There is a left-hand side, there is another window. This is command history. Command history. This command history provides all the commands which we executed in the recent past. I opened MATLAB at 10:48 a.m. 10:48 a.m. the first command I executed was 6 plus 3, and so on. We can see all the previously executed commands in the command list. And one more advantage of this command window is, if you double click this window, the command will be executed in the command window. If you double click this command in the command history, that command will be executed in the command window. So far, we are familiar with two windows. Am I right? One is command window, and another one is command history. Okay. So next thing is how to assign a value to a variable. That is as usual. If you give a is equal to, suppose I want to assign a value 5 to the variable a. Just a is equal to 5. So now I have a variable a. So from that we can get another variable b by taking this b cap to. B cap to means b is 25. Now you see the another window here, workspace. So workspace contains a is equal to 5, answer, that is sin square pi by 3 value, answer value, and b is equal to 25. So this is the workspace. Workspace contains all the running variables. Suppose c is equal to a plus 2b. You see on the left hand side corner, a plus 2. So another variable will come, c is equal to 55. So that means all the running variables will present in the workspace. So now we are familiar with three windows. One is command window, command history, and workspace. Okay. So I am giving another variable d here, like this b square, semicolon. I'm using semicolon. So there is no output here. But variable is there here. D is equal to 625. The difference between these two commands is semicolon. Semicolon suppress the output. Semicolon, MATLAB, if you give a semicolon, command will be executed and the output will be suppressed. Okay. So now we have A, B, C, D, four variables are. I'm using one command here, CLC, home command, HOM, first command, home. Sir, kindly mute your mic. So, home. If you give a home command, sir, kindly mute your mic, please. Okay, if you give home command, the cursor will go to left-hand side corner. But we can see the previous command by scrolling the scroll bar. If you give a home command, the cursor will go to left-hand side corner. And we can see the previous command.
అది కనీసం గంటలు తెలియాలిగా, పిల్లలకు తెలియాలి. వాటిని వెళ్ళాను, వస్తా, ఇక్కడ దాకా వాటిని వస్తా.
Sir, Madhuraj sir, kindly mute your mic, please. Okay, if you give a home command, the cursor will go to left-hand side corner. Whereas if you give a CLC command, it clears the command, it clears the window. We cannot see the previous commands. All the running variables will be present. If you give a CLC command, the command window will be clear. All the running variables will present. all the running variables will present. Suppose if you give a is equal to, that is there, everything is there. Just we are clearing the command window. And one more thing, so if you give a square root of b, sqrt of a, square root of a, square root of a, the MATLAB displayed the answer as 2.2361. Okay. Whereas previously we executed this value 1 by 2. Suppose if you take some x is equal to 1 by 2. Though the answer is 0.5, MATLAB is displaying the answer up to 4 decimal places. By default, MATLAB displays the answer up to 4 decimal places. 4 decimal places. Suppose if you want to see the answer, actually square root of 5, a is equal to 5 here. Square root of 5 is an irrational number. But MATLAB displays the answer up to 4 decimal places. Suppose if you want to see the answer up to certain number of decimal places, you have to change the format. Format. Suppose if you give format long. I'm executing the same command sqrt of 5. A, that is a is 5. The MATLAB displays the answer up to 15 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you give a format long, MATLAB displays the answer up to 15 decimal places. There are so many formatting techniques out there. I am explaining few. Format bank. You give a format bank. Anybody? What is the mistake here? Spelling. FRMA. Format bank. If you give a format bank, if you give a command format bank, I'm executing the same command sqrt of a, that is a square root of 5. Answer is displayed up to 2 decimal places. This is the format bank. Format bank display the answer up to 2 decimal places. Whereas if you give a format long, the answer will be displayed 15 decimal places. These are the formatting techniques. Suppose format rat. See the answer, square root of 3, square root of 5. It is 2889 by 1292. That means answer will be displayed as a rational number. Though it is a irrational number, MATLAB displays approximate rational number. Suppose if you give a is equal to y is equal to 1 by 2, now it displays 1 by 2, not 0.5, 0.5. Why? Because format is in rat. Okay. Now, I want to go to original format, standard format. For that, we have to give format. Now you give y. Y is previously 1 by 2. Now if you give y, that is 0.500. Now why? Because we are in standard format, default format. So these are the basics we should know before going to some interesting topics in MATLAB. Okay. So this is the getting started with MATLAB. How to enter a command, what are the windows, okay, how to execute the commands. These are the things we discussed so far. How to enter the commands, square root of log x base 10, exponential value, sin x, cos x, and so on. Okay, now I'm going to the first topic. So this is the basics. Now, how to create an array. Array means how to assign more than one value to a variable. Here a is previously we assigned a is equal to 5, b is equal to 25, c is equal to 55, like this. Now I want to assign more than one value to a variable. Suppose I am taking the same variable a, I want to assign more than one value. We have to follow some syntax. Then we'll discuss some interesting points, interesting topics in MATLAB. So 4, 5, space you have to give 7, 2, 4. So if now a contains more than one value, a contains 5 values, 4, 5, 7, 2, 1. So what is the size? Size of this array. Size of the array A. You see the left hand side. Previously the answer is 5. Now A contains 4, 5, 7, 2, 1. Size. Size of A. This 1, 5. 1 means one row. The array contains one row and 5 columns. 5 columns. So 1 by 5. Let's say row matrix. It is a row matrix. Next, we will learn how to enter a matrix in MATLAB. So now we are concentrating on a row matrix. Row matrix, that is an array. Simply we call it as array vector, row vector, like okay, row array. A is an array, contains 5 values. Now I am creating another array B is equal to A plus 2. A plus 2. This command 2 will be added to each and every element of the array. If you give B is equal to A plus 2, this type of operation is not available in MATLAB matrices, but we can add an element A plus 2. If you give A plus 2, 2 will be added each and every element of the array. Now I have two arrays. I have two arrays. One is A and another one is B. I have two arrays. One is A and another one is B. Suppose if you give A plus B, what happens? A plus B will get a new array that is 6 plus 4, 10, 5 plus 7, 12, 7 plus 9, 16, 2 plus 6, 2 plus 4, 6, 1 plus 3, 4. So if you give a plus B, it performs point-wise addition. Point-wise addition. Similarly, point-wise subtraction. A minus B. That's minus 2, minus 2, minus 2, minus 2 because B is A plus 2. My B is A plus 2. A minus A minus 2. That is minus 2, minus 2 array. Now I have two arrays, A and B. So now you have to concentrate on. If I give A plus B, the corresponding elements are added. If you give A minus B, corresponding elements are subtracted. So now I want to multiply the corresponding elements. Yes, we can use capital letters also. We can use, very good. So we can use very good. So variable, we can take capital A. Small A1, A is equal to some 0. A is equal to 9. Okay. So we can give A1. A1 is equal to 7. Not a problem. Caps, smalls, capital A, small a. 8. It takes. You can give your name. I can give my name. Srinivas is equal to 25. One variable is there on my name, that is 25. Okay. But one thing, alpha numeric we can give. Numeric alpha we cannot give. Suppose if I want to assign 1A is equal to 9, it will show error. You cannot assign a variable to numeric alpha. Alpha numeric you can assign. I hope you understand. Okay, sir? Okay. Now I have an array A, I have another array B. So if you give A plus B point-wise addition, you can perform point-wise addition, point-wise subtraction. Now my question is, I want to need a vector contains 4 into 6, 5 into 7, 7 into 9, 2 into 4, 1 into 3. Anybody, can you tell the command to get that answer? About theta, you have to write theta. You write down theta. What is that? THETA variable. No, TH you can write. Not a problem. Oh, I understood. Yes, that is a variable you are giving. TH is equal to. That is not a problem. 2. Left hand side is your choice. Left hand side is your choice. Theta you can take nothing. That is your convenient. A is there, B is there. I want to perform point-wise multiplication. I want to perform point-wise multiplication. Can you suggest any command? I want to perform point-wise. Oh, very good. Okay. No, sir. No. Why you are giving A star trans B? What is the reason? Why are you taking I didn't tell any this type of command. Tran B. A star tran B. I expected A star B some any at least. Okay. Now I'm going to this one. So for example, X and Y are there here, B and C. C is there here, D is there here. Am I right? Suppose if you give it C star D, it is coming 34375. That is 55 into 625. Similarly, I have A, this one, B is this one. Can it work, A star B? That is my question. If you give A star B, what happened? It's showing error. Did you understand my question? I need a vector 4 into 6 contains 4 into 6, 5 into 7, 7 into 9, 2 into 4, 1 into 3. Basically, here, if you give A star B, if you perform A plus B, you are getting point-wise addition, A minus B, point-wise subtraction. Whereas if you give A star B, we are getting an error because this is a vector of size 1 by 5. This is a vector of size 1 by 5. We cannot actually in MATLAB, star is defined for matrix multiplication. Star is defined for matrix multiplication. So we cannot multiply 1 by 5 matrix with 1 by 5 matrix. We cannot multiply 1 by 5 matrix with 1 by 5 matrix. Inner matrix dimension is not satisfied here. But I don't want to do matrix multiplication. I don't want to do matrix multiplication. I want to do different multiplication, point-wise multiplication. 6 into 4, 5 into 7, 7 into 9, 2 into 4, 1 into 3. So this is for matrix multiplication. A star, if A is a matrix, B is a matrix, and inner matrix dimension is same, then it will perform matrix multiplication. So whereas, suppose if you will get a doubt here, C is there here, D is there here. If you take A star B, we are getting matrix multiplication. Sorry, not A star B. C star D, we are getting answer. Am I correct? General multiplication. Why? Because what is size of D? You see this one? Size of C. Size of C. 1 by 1 matrix. Though we are giving a variable C as 5, it is taking as a matrix. Size C is 1 by 1. Size D is 1 by 1. We can multiply 1 by 1 matrix with 1 by 1. That is ordinary multiplication. Row with column. That is 55 into 675. We are getting the answer. C star D. We are getting the answer. Whereas here scenario is different. Size of A is 1 by 5. Size of B is 1 by 5. Inner matrix multiplication is not satisfying. Not same. Here 1 by 5 and 5 by 1 by 5. So we cannot do the matrix multiplication. That's why it is showing an error. A star B. But I don't want to do the matrix multiplication. I want to do point-wise multiplication. For that, we have to give like this. A dot star B. Dot is very powerful operator in MATLAB. If you give A dot star B, it perform point-wise multiplication. Point-wise multiplication. 4 into 6, 24. 5 into 7, 35. 7 into 9, 63. 2 into 4, 8. 1 into 3, 3. Okay. So if you want to perform point-wise multiplication, you have to give dot star. Suppose if you want to divide array with A, array with B, you have to give A dot by B. A dot by B. That means point-wise division. Point-wise division. A is this one, B is this one. A dot by B. That is 4 by 6, 5 by 7, 7 by 9, 2 by 4, 2 by 4, that is 0.5, 1 by 3, 0.3. Okay. Now I have array A. I want to square each and every element of the array. I want to square each and every element of the array. I want to square. That means I need an array 16, 25, 49, 4, 1. If you give A cap 2, it will show error. It will show error. Why? Because if you want to square a matrix, matrix must be a square matrix. This is hat symbol is for exponentiation of a matrix. A square, A cube, like this. So if you want to find out point-wise square, you have to give like this: A dot cap. A dot cap. If you give A dot cap to 4 will become 16, 25, 49, 4, 1 square is 1. A dot cap 2. Okay. Now I have A and B. I need an array A square B. That means 16 into 6, 5 square into 7, 7 square into 9, 2 square into 4, 1 square into 3. I need an array 4 square into 6, 5 square into 7, 7 square into 9, 2 square into 4, 1 square into 3. That means A square B. A square into B. Can you tell this command to find out A square B? I need an array A square B. Okay. Very good. Very good. This is the command to get the answer. A dot cap 2. A dot cap 2. Dot star B. A dot cap 2 is for A square, point-wise square. We are multiplying A square with B point-wise. Then only we'll get this answer. A dot cap 2 dot star B. Here no need to give the brackets. Why? Because here actually this is the thing we are doing. Here no need to give open braces. Straight away we can give. Oh, sorry. No need to give the brackets. Actually I have to give here. No need to. Here there is no need to give like this. There is no need to give the like this. Straight away we can give A dot cap 2 dot star B. So, and one more thing, most important thing is here, all inbuilt functions in MATLAB are point-wise, defined for point-wise. Suppose A is equal to this one. Suppose if you give SQRT of A, SQRT of A, it calculates square root of each and every element of the array. It calculates square root of each and every element of the array. Or here no need to give dot like this. So all inbuilt functions are defined to calculate point-wise. Okay, these are the inbuilt functions. Square root. Suppose sine of A. It calculates sine of 4, sine of 5, sine of 7, sine of 2, and sine of 5. Okay. Now I have an array x is equal to 3, 4, 5, 1. I don't want to display the answer. I have an array x. I want to calculate x square sin x. X square sin x. I want to calculate x square sin x. X square sin x. Can you tell me the command to calculate? I want to calculate x square sin x. I have an x value. I need x square sin x. That means 3 square into sin 3, 4 square into sin 4, 5 square into sin 5, 1 square into sin 1. Yes. I thought page enter out. Sir, there is a mistake in this. Sir, actually there is a mistake. In this call also there is a mistake. I am entering this one. Both are given syntax error commands. I am giving control V. What is the command? What is the correct command? We'll check this command. Control C. X square star sin x. So here there is a one mistake. Here 1, 2, 3 mistakes are 3 errors are there. The first one is x square. X square means pointwise. X dot cap 2. That is one error. X square sin x. We are trying to multiply x square with sin x. X square is correct. Sin x. Pointwise multiply. Dot star. Sin of x. Sin of x. Open braces are very important. Sin of x. Then only we'll get the answer. Then only we'll get the answer. Here, open braces are missing. Here, dot star, sin of x. Okay. So, this is the way of calculating the values. Okay. Now I have an array x. Here just previously we saw size of x. Size of x is 1 row, 4 columns. Okay. So if you give another command, there is a command, similar command, length, length of x. We give a command length of x. It will display how many elements are there in that array. 4 elements are there. That is the difference between size of x and length of x. Okay. Now we have array x. I'm talking about indexing. In MATLAB, indexing start from 1. That means x of 1. If you give x of 1, first element will be accessed. First element will be displayed. X of 1 means first element. X of 2, second element. X of end, last element. That is fourth element. X is this one. 3, 4, 5. X of end, last element. X of n minus 1. Last but one element. Is equal. X of n minus 1. X of n minus 1. And so on. Okay. So in MATLAB, indexing start from 1, first element, second element, third element, fourth element. Some programming languages, indexing starting from 0 also. In MATLAB, the indexing starting from 1. Suppose I want to replace third element by another element. We know how to access an element, third element. Suppose I want to replace third element by another element, third element. First we have to call the third element x of 3 by new element minus 2. I want to replace third element by minus 2. Previously we have x, that is 3, 4, 5, 1. Presently we have 3, 4, minus 1, 2. 3, 4, minus 1, 2. Suppose I want to replace first 2 elements at a time. I want to replace first 2 elements by new elements, or first 3 elements by another set of elements. First 2 elements by another set of elements. We have to follow some syntax. We have to call first 2 elements, first element and second element. But new elements, I want to replace 0 and 0. I want to replace first two elements by zeros. Okay, this is the way of accessing an element, replacing an element. Accessing and replacing an element. This is valid for any size of array. For explaining purpose, I have taken 4 elements. Okay, these commands will work for any type of array. Now I have an array X. I am taking another array Y is equal to X plus 2. Y is equal to X plus 2. Now I have two arrays. One is X and another one is Y. So I want to merge these two vectors. I want to merge these two vectors horizontally. Horizontal concatenation. I want to create another array. First X, next Y. For that, we have to give like this. Okay. I merged X and Y horizontally. This is the X. This is the X. Next, this is the Y. So how to do vertically? Next, suppose if you write, what will happen? Suppose X space Y space X. Okay, X space Y space X. That means first it will write X values, that is 0, 0, minus 2, 1. Next, Y values 2, 2, 3, 2, 2, 0, 3. Next, again X 2, 2, 0, 3. This is the array 0, 0, 2. This is the X value. Next, this is the Y value. Again, this is the X value. This is called horizontal concatenation. Horizontal concatenation. Horizontal merging. Horizontal merging. So how to merge vertically? That is matrix. Am I correct? X is this one. Y is this one. So now I want to merge horizontally. First I want to write 0, 0, minus 2, 1. Next, 2, 2, 0, minus 3. That means for that, this we are moving to matrices, the most important concept, matrices. X semicolon Y. X semicolon Y. That is I am shading, denoting as Z. That is Z. Now first row contains 0, 0, minus 2, 1. Second row contains 2, 2, 0, 3. So what is the size of A now? Size of G, size of Z. 2 rows, 4 columns. It's 2 by 4 matrix. 2 by 4 matrix. 2 rows and 4 columns. That means how to write a matrix now. Arrays are not over. Just I am giving a brief introduction. How to create a matrix. Suppose A. I want to create a matrix A with first row 1, 2, 3. With first row 1, 2, 3. So 1, 2, 3. Second row means we have to give a semicolon. I want to merge 1, 2, 3 with another row horizontally. 1, 2, 3, 3, 4, 4, semicolon. Another row with 7, 10, 12. Just have. This is my matrix, 3 by 3 matrix. Horizontal concatenation of 3 rows. Horizontal concatenation of 3 rows. Sorry, vertical concatenation of 3 rows. Vertical concatenation of 3 rows. What is the size of A now? Size of A. 3 by. Okay. So we know horizontal concatenation, horizontal concatenation and vertical concatenation. Okay. CLC. Now I'm going back arrays. So I have an array X here. 0, 0, minus 2, 1. Another array Y. We know how to merge horizontally, how to merge vertically. Then if you merge horizontally or vertically, we'll get another array. It may be array or a matrix. That is the second. Now, suppose x is there. What will happen if you give sum of x? Sum of x. Sum of x is a command. It sum each and every element of the array. That means 0 plus 0, 0 plus 0 minus 2 plus 1. Sum of x. If you give sum of product of y, where sum of x means sum of all the elements of x. Product of y means product of all the elements of y. 2 into 2 into 0 into 3. There 0 is there, some value. If you want to find out mean of x, mean of x means sum of all the values by number of values, mean value. It gives mean value. Okay, like that all statistical values, median, mode can be calculated. That's not our duty now. Just I am giving a brief introduction about these commands. Okay, next I am going to explain the most interesting concept, colon operator. Suppose what happened if you give a is equal to 2 colon 7. 2 colon 7. So now onwards you have to concentrate. You have to put some more effort. If you give a is equal to 2 colon 7, you will get an array starting from 2 up to 7 with increment 1. It gives array. If you give a is equal to 2 colon 7, it creates an array starting point 2 up to 7 with an increment 1. Suppose I want to give an increment 3. I want to create an array with another increment. We have to give like this. B is equal to 2 colon 3 colon 4 colon 9 15. We have an array 2 6 10 14. So that means starting point 2 up to 15 with increment 4. 2 first value 2, increment value 2 plus 4 6, 6 plus 4 10, 10 plus 4 14, 14 plus 4 18. We asked up to 15 only. So it stopped at 14. So this is the increment value. This is the increment value. This is the starting point. This is the end point, not end point, up to 50. So we can give any increment value. We can give the native increments. Suppose a is equal to 10 colon minus 2 colon 3. So we'll get an array 10, 8, 10 minus 2 8, 8 minus 2 6, 6 minus 2 4, 4 minus 2 2. We asked up to 3 only. So it stopped at 4. We can give x is equal to 2 colon 0.5 colon 6. Now we get an array 2, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. This is the space constraint. Due to less space, it wrote on the next line. It is not a column 1 to 8 and the 9th column. It's not a big issue. Y is equal. Not only here, we can give any value. So, for example, SQ or P of 2 colon 0.5 colon 6. The starting point, irrational number from this one to increment value 0.5, 0. Up to 6. Up to 6. This is the colon operator. Suppose I want to find sum of first 100 natural numbers. Can you give the command? Can you tell me the comment? I want to find sum of first 100 natural numbers. I want to find sum of first 100 natural number. 100 natural numbers. Can you tell me the comment to find sum of first 100 natural numbers? I want to find the sum of first 100 natural numbers using MATLAB. Anybody? Any guesses? Any guesses? I want to find sum of first 100 natural numbers. 100 natural. We need first 100 natural numbers. Am I right? That can be generated.
1 is to 100, sir.
Yes, 1 is to 100. I want to find sum of 100 natural numbers. Very good. Sum of 1 colon 100. So this generates 1 colon 100 generates 100 natural numbers. That is an array. I am taking sum. So we'll get 5050. Is it correct? Yes. Yes. Okay. So this is the thing. We need a sequence 1, 2, 3, 4 up to 700. That we can get by the command s is equal to whatever it may be. Left hand side is your choice. S is equal to 1 colon 100. We need an array 100 natural numbers. Then we have to add. First we need 100 natural numbers. That we can get by giving the command 1 colon 100. Sum of s. We'll get the answer. Can you tell me, with these, I spent 1 hour with about 11:35. With this basic commands, we can do wonders in MATLAB. Find the sum of the squares of first 100 natural numbers. Sum of the squares of 100 natural numbers. That means I need 1 square, 2 square, 3 square, 4 square, up to 100 square. After that, we have to add. How can we do that one? First, I need a 1 colon 100 natural numbers. Next, I have to square all the numbers. A dot cap 2 square each and every element of A point y square. Next, sum of B. A is equal to 1 colon 100. It generates 100 natural numbers. Next, B is equal to A dot cap to point y square, 1 square, 2 square, 3 square, up to 100 square. Next, sum of the elements, sum of B.
Sir, can we write this as a 1 notation?
Tell me, 1.
No, whole of this process is sum of the squares of first n 100 natural numbers as 1 command.
Tell me, what is it? Tell me. Sum of
Squares of first 100 natural numbers, but only as 1 command, not as A, B, and then sum. Is it possible?
Okay. Yes. Sum of, am I correct? You see this one. 1 colon 100 dot cap 2. Same value.
Okay.
No, this is to understand. I have given like this. To understand these 3 commands. To understand the concept, I have given like this. So this is 1 colon 100. Am I right? This 1 colon 100 is 100 natural numbers. Point y square. Sum. Is it clear?
Yes, sir.
No. So this is the thing. Okay. With this, now I am moving to matrices. Then I will discuss some important linear algebra concepts. Now I am taking one matrix A is equal to first row 1 space 2 space 3, second 3 space 4 space 4, 7 space 10 space 4. I'm taking one matrix. I created one matrix of order 3 by 3, 3 rows and 3 columns. Okay, so already I told size of the 3 by 3 matrix. Suppose if you want to find out the diagonal elements, DIAG of A. So basic things we know to learn some linear algebra concepts and linear algebra. Diagonal of A. If you give DIAG of A, you will get diagonal elements. So 1, 4, 12. If you give A transpose, if you give A is equal to A dash, I'm taking as R has given, Reddy sir has given PRAN, that's not the correct command. So we have to give, if you want to find out the transpose, you have to give A dash. Okay. Transpose of A. Transpose of A. A is equal to this one. B is equal to this one. B is the transpose of A. First row. First row is first column. Second row is second column. Third row is third column. Okay. Transpose. Now I want to find out the det of A. Determinant of A. That is minus 2. Determinant is not equal to 0. We can find out inverse. Inverse of A. Inverse of A. So determinant is not equal to 0. Rank is always 3. 3 by 3 matrix. Am I correct? Rank of A. You want to find out the rank of the matrix? Give rank. Because data value is not equal to 0. Rank is equal to non-singular matrix. So rank is always equal to the size of the matrix, order of the matrix. Okay. So rank, determinant, inverse. Okay. Next. So this is for any type of matrix. Suppose I am taking some P. I have taken a P matrix or 6 by 6 matrix. First I created one 6 by 6 matrix. Okay, 6 by 6 matrix. So det P. Actually, if you want to calculate determinant of P 6 by 6 matrix, 8 into 5 by 5 matrix, minus 3 into 5 by 5, minus 10 into 5 by 5 det, minus 8 into 5 by 5, 7 into 5 by 5 matrix, again 7 into 5 by 5 matrix, that value. Again 5 by 5, you have to convert to 3 by 3, 3 by 3 again 2 by 2, then finally you get the answer. So that is the value is minus 7994. Whatever I am telling, all these commands valid any size of the matrix, inverse of P. This is the 6 by 6 inverse matrix. Okay. Now A is there with me. A is there with me. Now my goal is how to perform elementary row and column operations on this matrix. For that, we have to know, we have to start from the beginning. How to access an element, how to access an array, how to access more than one rows, more than one row, how to access one single column, how to access more than single column, like that. So how to access an element in a matrix. So we have to mention row and as well as column. Second row, third column element. If you give second row, third column element, that is 3. That is 4. Okay. Second row, first column element. Second row, first column element, that is. You want to access an element from a matrix, you have to mention row and as well as column. Now I have an array. We know how to access an element, how to access a particular element. Now how to access a row. I want to access a row. How to access a row? Row means first row, all column elements. First row, all column elements. Colon represents all. Okay. First row, all column elements. First row, all column elements of A. Similarly, if you want to access second row, all column elements of second row. Suppose if you want to access first column, you have to give first column, all row elements of first column. That is 137. 137. Now A is there. We know how to access the first row. Am I correct? So how to access second row, for example, third row we can access like this: 3, all row elements. I want to replace third row by another row elements. I want to replace third row by another row elements. That we have to give like this. Another row, 7. If you give like this, A of 3, colon is equal to 7, 5, 7, 3. Instead of 7, 10, 12, we'll get another. Third row by another. Suppose if you want to access, if you want to replace third column by another column, A of colon, 3 with element 0, 0, 0. Okay, so previously third row is 3, 4, 3. Now present third row is 0, 0, 0. Now I'm going to original A matrix. I created this original one. Okay, this one. Here's the matrix. Now I want to multiply first row with 2 times of R1 changes, 2 times of R1. I want to multiply the first row element, the first elementary row operation. I want to perform first elementary row operation. That is Ri changeless, K times of R. Ri interchange, whatever it means. Ri goes Ri plus K into Ri. That means I want to write in the place of R1, 2 R1. First we have to access the first row. How to access the first row? First row, all column elements is equal to 2 times of the first row. 2 times of the first row means actually we have to take, I want to replace 2, 4, 6. I want to replace with 2, 4, 6. Actually 2, 4, 6 is what? 2, 4, 6. If you give this command, instead of 1, 2, 3, it will come as 2, 4, 6, 3, 4, 4, 7, 10, 12. This is nothing but 2 times of A of 1, colon. This one. A of 1, colon is nothing but first row. That is 1, 2, 3. I am multiplying with 2. That is 2, 4, 6. I am writing 2, 4, 6 in the place of first row. R1 changed as 2 times of R1. R1 changed as 2 times of R1. Oh, next. Suppose I want to perform R1 change, R2 changes R2 minus 2 2R1, for example. I want to perform I'm opening the pen. One second. Okay. I want to perform this elemental operation. R2 changes. R2 plus 2R. So in the case of second row, I want to write R2 plus 2R1. Second row plus 2 times of R1. So first we have to access R2, second row. How can we access the second row? A of second row, all column elements. I have to replace this one with this vector by this row by or vector by R2 plus 2R1. How to create this R? How to make this R2 plus 2R1 A of 2 comma column. This A of 2 comma column plus 2 times of R1. R1 is nothing but A of 1 comma column. If you perform this command, if you give this command to MATLAB, it will perform the array elementary row operation. R2 changes R2 plus 2R1. We'll check it. R2 A of 2 comma column equal to A of 2 comma column R2 plus 2 times of R1 A of 1 comma. If you give this command, see this one, R2 2 plus 4 7 4 plus 8 12 4 plus 12 16. So now we know how to perform first elementary row operation. Elementary operation Ri changes k times of Ri. Next elementary operation Ri changes Ri plus krj. Next interchanging of rows. Interchanging of rows is very simple. K is this one with me. If you want to interchange these two rows, A of we select 2 comma 3. I'm selecting 2 rows with all column elements. I'm replacing with 3 comma 2 with all elements. Then second and third are interchanged. If you know these basic commands, we can perform, we can solve system of equations. We can perform all echelon. If you want to solve the system of equation using echelon form or Gauss ideal, Gauss Jordan, we can do. This is the way of performing elementary row operations on a matrix. Elementary row operation in a matrix. One thing I forgot to tell you, how to find out the eigenvalues and eigenvectors. I'm taking one vector, 1, 1, 3. 151. Matrix 3, 1. This is my one matrix A. If you want to find out the eigenvalues. So what is the definition of an eigenvalue and eigenvector for a given square matrix? If there exists a non-zero column vector x such that Ax is equal to lambda x, then x is called eigenvalue, eigenvector, lambda is called eigenvector. The process is first we find out characteristic polynomial equation. Next, we'll solve that equation. We'll get roots. Those are the eigenvalues. First, we'll get a characteristic equation. Further, we write that of a minus lambda. We write a minus lambda. We take this is the classroom procedure. We take a minus lambda. That of a minus lambda is equal to 0. Depending upon the equation, we'll get a polynomial equation. If it is a third order, at most will third degree polynomial equation. If it is a fourth degree polynomial equation. Then after solving this equation, we'll get the eigenvalues lambda 1, lambda 2, lambda. If it is a third order, we'll get at most 3 eigenvalues. So how to do these things on MATLAB? This is determinant that of a minus lambda. This we can get polynomial equation. We can get by taking a command poly of e. Poly of e. This is a polynomial equation. The equation is here. We'll get a coefficients of a polynomial lambda square, lambda cube. Third degree it is lambda cube minus 7 lambda square there is no lambda coefficient plus 36. This is a characteristic polynomial equation. These are the coefficients of the characteristic polynomial. So now we have a characteristic equation. We need the roots. Those are the eigenvalues. Roots of poly of e. The eigenvalues of this matrix are 6, 3, minus 2. Eigenvalues of this matrix 1, 1, 3, 1, 5, 1, 3, 1. So if you want to find out eigenvectors, so we are asking two values. So we are giving the commodity. That is your choice. Any name you can take left answer. EIG of E. No. First of all, I have to tell one more command. So straight away, I need eigenvalues. We can give a command EIG of. We'll get the eigenvalues minus 2, 3, 6. You can, if you want to find out the eigenvalues from a polynomial equation, you take like this. That means the first polynomial equation roots. Straight away, these two commands are seen. Okay. From these two commands, we can get eigenvalues. Suppose I need eigenvectors also. Is with me. I need eigenvalues and eigenvectors. For that, got to give this is the first eigenvector corresponding to the eigenvalue. Left hand side is your choice. So vector and diagonal matrix. That is the thing. That's why I put V comma D. You can give any name. First eigenvalue is this one. Second eigenvalue. Third eigenvalue. Diagonalize the matrix. The corresponding eigenvector. This is the eigenvector corresponding to this eigenvalue. This is the eigenvector corresponding to this eigenvalue. This is the eigenvector corresponding to this eigenvalue. Okay. So time is very limited time. So Next, with this, I am closing this linear algebra. I explained some linear algebra concepts. Next, I am going to explain plotting techniques. It is a somewhat interesting topic in MATLAB. Visualization. Visualization. Suppose I want to plot y is equal to, next topic, last topic I am moving, y is equal to x square. This is plotting techniques. I am going to explain plotting techniques. I want to plot y is equal to x square in -3 to +3. Usually what we do in the classroom, first we take x values, few values, -3, -2. Few values we take -1, 0, 1, 2, 3, and we square these elements. Y is equal to x square, y values, that is x square, y is nothing but x square. Nine, 4, 1, 0, 1, 4, 9. Then we take a paper, like a graph paper, we take x-axis and y-axis, and -3. Corresponding point is 9. That is the point 9. -2. Corresponding value is 4. X is equal to -1, -1, -1, 1, 0, next 1, 4, 9. Then we join all the lines by, we know it is a parabola. We do like this. Now we have to do all these things on MATLAB. This is minus. Anybody, how to create this x value? Can you give a command? Can you tell me the command to create this array? It is an array containing -3, -1, -3, -2, -1, 0, 1, 2, 3. First, I need this array. Then I have to square this array. I have to square. How to do this one? How can we create the array containing -3, -2, -1, 0, 1, 2, 3? This we can create by a command x is equal to -3 column. Starting point -3, increment 1 up to 3. If you give this command, this array will be generated. Next, I have to square each and every element of x. I have to square each and every element of the x. Y is equal to x square, x dot capital. This is the x value. If you square each and every element, you have to square each and every element pointwise. So y is equal to x dot capital. Now I have this row and as well as I have this row. If you perform these two commands, these two arrays will be generated. Next, I have to plot. There is a simple command if you want to plot x versus y. You have to give plot x comma y. Standard command is plot x comma y. Options are there. Plot. If you enter these three commands, you will get a plot of y is equal to x square in y is equal to x square. Okay, we see all these commands. We perform one by one. First, I want to plot y is equal to x square. First, I am taking y. X is equal to minus 3 colon 3. That is x value. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Y is equal to x dot cap. Y is equal to x dot cap. Plot x comma. If you give this command, MATLAB generates a plot y is equal to x square. It is not a smooth curve. Am I correct or not? You see this one. These are some here data cursor is there. If you select the data cursor, it will show the points. This is the first point. Minus 3, 9. Next. This is the second point. Minus 2, comma 4. This minus 1, comma 1, 0, comma 0. 1, comma 1. 2, comma 3, comma 9. See, actually MATLAB perform here. The first point is this one. Second point is this one. MATLAB drawing these consecutive points by straight line. These two consecutive points by straight line. Again, straight line. Straight line. That's why it's not. It doesn't look like it's not in. It's like a parabola. Okay. So if you take more points, more number of points, you'll get a smooth curve. So I am taking interval length now. This is the original command I have given x. I am taking interval 0.1 colon. Minus 3 colon 0.1 colon 3. What is size of x? 61 points are there. 0 to 3, 30 points. Minus 3 to 0, 30 points. Interval length is 0.1. 30 plus 30, 60. 60, middle 0, 1, 61 points. So x contains 61 points. Y is equal to x dot cap. X dot cap. Now we take a plot. Plot of x comma. See that? Now it looks like a parabola. So because there are first point minus 3 to plus 3, second point third, fourth, and so on. There are 30 points over next remaining 30 points. Each consecutive point joined by a straight line. So if you take more number of points, you get a smooth curve. You take this one. What is the basic command here? Okay, this is the command. This window we call it as a figure window. There is another window in MATLAB. All figures are, if you want to, figure window contains figures, drawing, plotting curves, plottings. Okay, so now how to give a x-axis name? We have to give x. Usually we give x-axis, y-axis, and title of the curve. For that we can give x label. X-axis. Give x label. X-axis. X-axis. Next, y label. y-axis, x-axis, y-axis. Next title, I want to do the title to this title. Y is equal to x square plus title. Y is equal to x square. If you want to save this as, we can save, and we can copy, save. If you can save as JPG, if you want to give a figure view, you can save so many. If you want to save, you give a save. There are so many. You can save any format. Any format you can save, and you can save in the MATLAB current directory. Whenever you want, you can paste in Word document and so on. Suppose I am saving as a JPG file. I'm saving as a JPG file name as JMJ save. Okay, that will be saved in current directory. There is another directory there. Next window, JMJ. All the saved files will be saved in JMJ, where it is saved. JMJ. Yes. I saved as a JMJ file. So there are two windows are there. One is current directory, workspace. Workspace is running variables, current directory. All saved files will be saved in current directory. Saved. Now I am copying this one. Copy. You can paste it. I saved as JPG file. This is the JPG file. You can copy and paste in your document. Okay. This is the way of plotting 2D curve, single curve. So I plot y is equal to x square curve in -3 to +3. I plot it. That's it. Suppose if you want to plot more than one curve, suppose I want to plot y is equal to sin x, y is equal to 2 sin x, y is equal to 3 sin x. I want to plot 3 curves in a single window. First, I want to plot x is equal to 0 to 2 pi. My interval length is 0 to 2 pi. 0 to 2 pi. I want to plot y is equal to sin x, y is equal to 2 sin x, y is equal to 3 sin x in 0 to 2 pi. In the interval 0 to 2 pi. So x values, x is equal to 0.01 interval length, 2 star a. Y is equal to sin of x. Second, y1, 2 star sin x. Y2, 3 star sin of x. y1, y2, y3. I have three values. One is y is equal to sin x, y is equal to 2 sin x, y is equal to 3 sin x. Now, if you want to plot more than one curve, plot x comma y, comma x comma y1, comma x comma x versus y, x versus y1, x versus y2. If you give this command, to give a command, this is y is equal to sin x curve, y is equal to 2 sin x curve, y is equal to 3 sin x curve. How to identify these curves? How to identify these curves? So there is a command, legend command here. If you give a legend, data one, first data, this blue color, data one. What is the data one here? X versus y. X versus y means sin x. So if you double click here, sin x. Next, this green color is this one, data 2. Data 2 is x versus y1. Y1 is 2 sin x. Sin x. Data 3, red color is data 3. Data 3 is this one. Data 3 is third data. First data, second data, third data. Third data is 3 sin x. There is another command, grid command, grid. If you give a grid command, will it look like a graph paper. Now we can give labels x-axis, y-axis, title also. Title, and that is common. That's x label. X label. X-axis, y label, y-axis, sin x, sin x, this is the x-axis, y-axis, sin x, 2 sin x, 3 sin x curves. Okay. If you want to remove this also, we can remove this place also. Okay. That our commands are there. Access command is there. This is the way of plotting more than one curve in a single window. More than one curve in a single window. This is about 2D plotting. So we can give colors also. We can change markers and all this we can do. Actually, original I will show by this one. So these are options. The actual basic command of MATLAB is plotting command is plot x comma y option. So in these options, we can give markers also. We can change the blue if you want blue color curve. For example, blue color, red color. By default, MATLAB uses blue color. If you want to make it as a red color or magenta color or gray color, black or green, yellow, you have to give. If you want to display the curve in red color, we have to mention as R as an option. Magenta color means M as a M. If you want to display the answer in black color, we have to make it as a K. For example, you see this one. X value is there. Plot x comma only one curve I am taking x comma y comma plot x comma y. If you give this one, it will color in blue color, sin x color. Sin x curve in 0 to 2 curve. That will be blue color. Suppose if you give the command like this, plot x comma y option or red color. The curve will be displayed in red in color. Okay. Suppose if you give plot x comma y with markers, I want to display the points with dots. Dots. Actually, dots are joined. Dots with dots, or otherwise more points are there. That's what is coming like this, dot by dot. Suppose if you give both circles, there will be displayed as circles. Each circle, these are the circles. Circles. More number of points are there. That's what it is giving. It's showing like this. Suppose I will, if you reduce size 0.1, I'm taking as less number. I have taken less number of points. Y is equal to sin of x dot x comma y comma. I have taken less number of points here. Curve is joined by circles. So I want to display the curve with marker circle, marker as a circle, color in red color. So I have to give circle or red circle marker. These are the so many options are available. I use a dot circle red color. Mix it. You want to take a square, you want to take marker as a square, I take S. Okay, diamonds D plus like this. Dot x comma y comma colon. Two markers. So like this we can do red color. If you want to call red color means R. You can use two markers also. This is about 2D plotting. Like this we can the basic plot command is plot x comma y options. If you want to plot more than one curve, we have to take x versus first data, x versus second data, x versus third data. So very simple. These are the very two simple commands I explained to generate a plots in MATLAB. Next, I will explain one 3D plot. Then I will close the session. Suppose I want to plot x is equal to z is equal to x square plus y square. 3D plot. X square plus y square. I am going to z is a dependent variable, x comma y are independent variable. It's two independent variables, one dependent variable. So I want to plot in between x minus 3 less than or equal to x comma y. X value minus 3 to plus 3, y value also minus 3 to plus 3. I want to plot z is equal to x square plus y square. So first we take x value, x is equal to, first we will define x value, x is equal to minus 3 colon 0.1 colon 3, y is equal to minus 3 colon 0.1 colon 3. Yes, z is equal. Now, so I will explain. Now I have taken x is equal to y values. Now we generate a grid for 3D plot. We have to generate a grid x plus y. I will explain these commands. First I will generate the curve, then I will show the mesh grid. Of x comma y. Now z value, z is equal to x dot f2. Now I have x value, y value, and z value. The 3D plot for the 3D command, if you want to generate 3D, you have to take mesh or surf, surface, x comma, y comma, z. Now this is the 3-dimensional plot. This is the 3D plot. Actually, this is the values I have taken first. Before that one, I will give x, y, z. I will give x label, y label. Then you can easily understand. X label, x axis, y label, y axis, z label, z axis. Now you see this plot. Now x-axis is there. This is x-axis. This is y-axis. This is z-axis. Rotation. I want to show first x-axis, y-axis. So this is the x-axis. Minus x values minus 3 to plus 3. Y values minus 3 to plus 3. This is the origin 0, 0, 0. This is the origin. So the first we have created minus 3 to plus 3, minus 3 to plus 3 with increment 0.1, minus 3 to plus 3. There are 61 points are there here. 0 to 1, 10 points. 1 to 2, 10 points. 2 to 3, 10 points. This is x-axis. This is y-axis. So we have taken x values and y values first. Like this. Minus 3x value. This is minus 3. Plus 3. This is 0. X is equal to 0. This is x values. 0. I have taken 61 points on the x-axis. Similarly, y-axis minus 3 to plus 3. 0. With the help of this command, I created a grids, ordered pairs. 61 into 61, ordered pairs. 61 into 61 ordered pairs. Each one is an ordered pair. This is 0, 0. This is some value like this. That is this diagram. That is this one. Okay. This is 0. Here 0. This is 0, 0. This point is 0, 0. So here 61 points are there. Here 61 points are there. 61 into 61. What is the value? 61 into 61 approximately 61 into 61. 3,721 ordered pairs are there. 3,700 ordered pairs are there. 3,721 ordered pairs. One among them is 0, 0. This is 0, 0. This is -3, -3. This is 3, 3. Here 3, 3. Here x value -3, y value 3. Like this. Now, this is the first command. With this, somebody asked. Sir, we can just use x title. No, sir. X label command is label. If you want to label a label, you have to give X label. For title, we can give title is different. X label for X axis, Y label for Y axis, Z label for Z axis. Suppose title is total title graph. Okay. That I will come back. First, I will complete this part. So we have a mesh grid. After that one, we have mesh grid, and later for each point x comma y, I calculated z. I have x value, y value, z value, triplet I have. With that triplet, if we give a surf command, MATLAB created this one. Okay, now x-axis, y-axis, z-axis. Title. Next, title. Z is equal to x cap 2, y cap 2. The title command. Z is equal to x square plus y square. Okay, with this, I am closing the session. So this is 2 hours is not sufficient. Actually, I plan to take my research topic. This is more than this MATLAB. MATLAB is somewhat interesting. Okay. So actually, Madam organizers asked me to take my research topic. So I have very bad experience. If I teach my research topic, no one, only 10 minutes they will interact, only 10 minutes. After that, no one will listen, no one will concentrate on the topic. Okay, that's why I've chosen this MATLAB topic. It will create some interest.
Yes, sir. Yes.
Thank you, madam. Thank you.
Thank you, sir. Thank you, sir.
Thank you very much, Dr. Srinivas Rao, sir, for giving a nice presentation on pedagogical learning of MATLAB. Thank you very much, sir, for sharing your knowledge on MATLAB. Sir, the topics you covered today, like MATLAB operations, how to use MATLAB operations, how to create an array, linear algebra concepts, how to use elementary row and column operations on matrices, how to calculate eigenvalues, characteristic values, and plotting techniques are very important for every participant of this FDP. Now, it's time for question and answer section. Shall we start, sir?
Yes, ma'am. Yes, sure.
I request the participants of the FDP to interact on today's session, MATLAB. Sir is ready to answer the questions. Really, it's a benefiting platform to stimulate and enhance our understanding of the MATLAB by exploring our doubts and questions. If anybody having doubts, please unmute your mobile and ask the resource person or post your query in the chat box also.
Any questions? Yes, sir.
Sir, no one has any questions, sir. We have shortage of time
Yes, sir, we can use Scilab also.
to move on to validity function. Once again, thank you so much, sir. Before moving to validity, I request Dr. Soma Maheshwari, madam, to give you a word of appreciation on today's session.
Sir, I explained, sir. What about 3D shapes representation? That also we can do, sir. This time is very short, so I explained only 3D plot.
Okay, sir. On behalf of JMJ College Faculty Development Program Organizing Committee, I sincerely thank today's eminent speaker, Dr. K. Srinivas Rao sir, for taking time from his hectic schedule to impart knowledge on various techniques in MATLAB and its significance in the field of technology and science. Sir, your presentation on the topics like getting started with MATLAB, relational and logical operators, and linear algebra concepts are more enriching and enlightening. Handling of arrays and matrices and plotting of 2D and 3D graphs by taking many examples are very precise, lucid, and highly informative for both scholars and faculty members. The main importance of today's session is intended for the broader academic community who seeks to explore the impact of MATLAB in the academics and various fields. The session also provided us with a personalized hands-on experience that is rich with technical knowledge. Sir, your presentation drew the audience in and held their attention for 2 full hours. There was never a dull moment. Sir, you deserve our special compliments and praise. I am sure we have greatly benefited from your wonderful session on MATLAB. Once again, I thank you, sir, for the unflinching support and coordination. Now, it's time to move on to valedictory function. The time has come to draw a curtain to our faculty development program. Warm welcome to all of you, the valedictory session of this FDP. As we come to the valedictory function, I now take this opportunity to welcome our honorable correspondent, Dr. Sister Teresonna Gade, our respected faculty members and research scholars present here. I am thankful to all the participants for attending 5 days national level FDP, and I am sure that the participants must have benefited by attending the conference. Now, presentation of the report. Now, I would like to request Mrs. C.M. Anita, Head of the Department of Physics, Organizing Secretary of the FDP, to present the 5-day FDP report.
Thank you, Uma. Good afternoon, one and all. Departments of Physics and Mathematics organized 5-day national level online FDP on effective pedagogy for science from 29th November to 3rd December. On the first day, Professor B. Ravisankar Babu, former HOD of Physics, University of Calicut, Kerala, gave his talk on Introduction to Astrophysics. Astrophysics is the study of the planets, the sun and the stars, the Milky Way galaxy and other galaxies, the interstellar medium and the intergalactic medium and the universe itself. This study is aided by our knowledge of the laws of physics discovered by experiments carried out in laboratories. Professor B. Ravisankar Babu enlightened the participants with interesting topics on radius of typical galaxy, measurement of linear media distance, parsec value, lifetime of star, total energy of sun, magnitudes and distances, ratio of first group and sixth group stars and black bodies, photographic and visual magnitudes, stellar spectroscopy, Harvard stars, etc. On the second day, Dr. Raju Venkatnarayana, an outstanding DRDO scientist, gave his talk on Introduction to Radar for Defense Applications, an effective pedagogical approach. Radar is an electromagnetic system for the detection and location of target objects such as aircraft, ships, spacecraft, vehicles, people, and the natural environment, which can reflect a signal back. It uses electromagnetic radio waves to determine the angle, range, or velocity of objects. In this connection, Dr. Raju Venkatnarayana explained about radar subsystems, commonly used terminology in radar, functions of radar equation, radar frequency, classification of radar, non-military applications of radar. He showed different radars made under his guidance. On the third day, the talk entitled An Introduction to Wavelets and Wavelet Transforms was delivered by Dr. Sunil Kumar Singh, Associate Professor and Head of Mathematics, Baba Saheb Bhimrao Ambedkar University, Lucknow. The talk emphasized about the concepts of wavelets which are developed independently in the fields of mathematics, quantum physics, electrical engineering, and seismographic geology. Interchanges between these fields during last 10 years have led to many new wavelet applications such as image compression, turbulence, human vision, radar, and earthquake prediction. In his talk, he emphasized that wavelets are mathematical functions that cut up data into different frequency components and then study each component with a resolution matched to its scale. On the fourth day, the e-talk entitled Normal ADLs, Relatively Dual Normal ADL was delivered by Captain Dr. S. Ravikumar, Professor, Department of Mathematics, AUCSG, Andhra University, Visakhapatnam. Professor Ravikumar sir focused on his topic almost distributive lattices and its normal, dual and relatively normal concepts and very relevant to recent research. He also derived normal ADLs in terms of its prime ideals and minimal prime ideals. Also, he discussed the concepts of annihilators, dual annihilators, and relative dual annihilators in an ADL and some of their properties. He characterized relatively dual normal ADL in terms of relative dual annihilators. On the fifth day, the e-talk entitled Pedagogical Learning of MATLAB was delivered by Dr. K. Srinivas Rao, Professor and Head of Mathematics, Sri Chandrasekhara Endra Saraswati Viswa Mahavidyalaya, Kanchipuram, Tamil Nadu. Dr. K. Srinivas Rao introduced MATLAB, an efficient, user-friendly interactive software package which is very effective for solving engineering, mathematical, and system problems. According to him, MATLAB is a high-performance fourth-generation programming language which is used for technical computing. It provides multi-paradigm numerical computing environment and was developed by MathWorks. He told that MATLAB's built-in functions provide excellent tools for linear algebra computations, data analysis, signal processing, optimization, numerical solution for ODS and PDS. In his talk, he covered topics like how to start with MATLAB, handling of arrays and matrices, linear algebra concepts, relational and logical operators, and plotting of 2D and 3D techniques. Thank you, one and all.
Thank you, Madam.
On behalf of the management, I take this opportunity to congratulate and thank for conducting 5-day national level online faculty development program on effective pedagogy for science. My special thanks to all the resource eminent persons, professors, scientists for enlightening all the participants on various topics related to present knowledge and technology. Thank you, sir, for your vast experience sharing with us from different universities from far and wide online program which made us come close together and enlightening and gaining knowledge from various topics. And I thank for taking so much trouble and to give a beautiful speeches or lectures on the topics as the participants are very much satisfied with your useful experience and knowledge. I thank Dr. S. Uma Maheshwari, convener, HOD Mathematics, and Miss C. M. Anita, HOD Physics, organizing secretary, for taking so much trouble to organize and to contact various persons for this seminar and planning meticulously. 5 days is a heavy, hectic program, but still we have very much planned and arranged well for a successful seminar. And I also thank all the faculty members of physics and maths departments for your cooperation and support to arrange this seminar. And I also thank all the participants for responding to this seminar and participating. Hope you have gained a lot of knowledge about latest topics and technology. And I thank Murali and Ravi for assisting us online program with the computers and technology and seeing every minute that everything goes on well. And I also thank once again all the resource persons, organizers for making fruitful and successful this seminar and which is very much enriching and latest developments in the knowledge with regard to the pedagogy of science. Once again, thank you one and all. Thank you.
Your mic is in mute, man. Madam, you are in mute.
Dear participants, here is a special note. Feedback link will be sent to your registered emails after completion of the session. On behalf of the organizing committee, once again, thank you all. Now, we close our FDP program.
Thank you. So congratulations. పర్వాలేదు మామూలుగా 12 o'clock అట్లా అయిపోద్దాం అనుకొని అవును ఈరోజు ఎక్కువ తీసుకుని అదే
సెక్షన్ అయ్యేసరికి
మ్యూట్ చేసాను.
అదే చూస్తున్నా ఇదేందుకు కావటం లేదు అందుకే తీయబ్బా ఇది మీట్ చేయి
అయిపోయింది.